Hey guys, we're going to do another chapter 1 video here. This time we are moving into topic 1.5 if you're following along in our book. And go ahead and set up your notes, write today's date and our essential question. And our essential question today that we're going to work on is, what is a literal equation and how do I solve it? So this whole chapter, this whole first beginning part of our book is just about how do we solve equations, and kind of reviewing and making sure everybody has the same set of skills going forward for the rest of algebra. And a literal equation is something you're going to need to know how to solve. So we're going to jump into it today and kind of take a look at it. To kick things off, let's do an example. So this is the kind of examples that we've been doing in the previous videos. Solve for x. And here's our problem. X plus 5 equals 2x minus 6. This is a really typical equation. The name of this equation is called a single variable because there's only one variable. The variable's x. I know there's an x on the left and there's a 2x on the right, so there's a lot of x's, but there's only x. There's no y, there's no z, there's no other variable letter. So we call this a single variable problem, and these are the ones we've typically been practicing solving. We put our line down the equal sign. We want to get x all by itself. In this one, I'm going to move the x over to the 2x. I'm going to combine like terms. So if I get rid of the x's, what I'm going to get is 5 equals 2x take away an x. So 2x take away an x would be 1x, and then a minus 6. And I'm almost done already. I'm going to add that 6 to the other side to get rid of it. That way x is isolated all by itself, and 5 plus 6 is 11, and that's our answer. Now, we've already practiced a bunch of these, so that problem should have been like, oh yeah, I followed along and I got it, and it was pretty easy. And it comes out to a nice answer, x equals 11. Typically, you get a nice answer, a nice solution when you have single variable problems. Usually you do all of your work and at the end you have an answer. I mean, not always. You saw in the earlier videos, sometimes you can have no solution or all real numbers, but mostly you get a nice answer. But now we're going to get into a new type of equation today. We're going to do a second example. And in this example, we are going to do the same thing. We're going to solve for x, but here's the equation. 2x minus 8y equals 4. 2x minus 8y equals 4. So this one's different. It has an x and a y. It's got two variables, so we call this a multivariable equation. And when we solve a multivariable equation, we do it just like we do every other equation. We put the line down the equal sign. Our job is to solve for x, so we're going to get x isolated by itself, and we're going to get an answer. Except this answer is going to look a little bit weirder. So if we're going to get x all by itself on the left, we got to move everything over to the other side. Like that minus 8y, we got to move it. So I'm going to add the 8y to the other side to move it out of the way. That way, all I have is 2x on the left. On the right, I have 4 plus 8y, but 4 plus 8y, yeah, it's not 12. You can't add those together. A 4 is a regular number, and an 8y, oh my gosh, both my puppy dogs are jumping up on the couch here. Max, sit down. So a 4 plus 8y, you can't combine those together. So I'm just going to write it like it sounds. 4 plus 8y. Nothing else I can do there. But remember, we're solving for x. So it's a 2x, and we got to get rid of the 2. So to get rid of the 2, we divide. We're going to divide by 2 on the left and the right. But look what I have to do. I have to do a big division equation. I have to divide everything on the left and everything on the right. It'll get rid of my 2's, but look what I'm left with. I have x equals 4 plus 8y divided by 2. Well, that's 4 divided by 2, and that's 8y divided by 2. That's actually easy math. 4 divided by 2 is 2, so x is going to equal 2 plus 8y divided by 2. 8 divided by 2 is 4, so it would be 4y. And there's our answer. X equals 2 plus 4y. That's our solution for x. So with multivariable equations, typically you get really messy solutions. You get messy answers. They don't turn out to like a nice number like x equals 5. They can, but a lot of times they don't. So I call that a messy solution. X equals 2 plus 4y. It looks messy to me. And eventually, that equation might mean something to me. Right now, it doesn't really mean much to me. We solved for x, but now I'm like, okay, why'd I do it? Eventually, in class, there's going to be a reason for why we do that. There's going to be some applications. It's going to make more sense. But right now, we're just practicing the skill. Can you solve for x? And later, you're going to apply that skill to like real world stuff where it actually is applicable to something that makes sense. So another name for this process is we call it literal equations. A literal equation is a multivariable equation, but typically it's ones that we know that stand for things. I'll give you some examples here. D equals R times T. Distance equals rate times time. Remember we did this in class earlier this year? This is a literal equation. It's multivariable. It's got three variables, D, R, and T. But it's also literal because D stands for distance, R stands for rate, and T stands for time. It stands for something. And we can play around with this literal equation. Like we could solve for R. Right now it's solved for D. It says D equals. But we could rearrange it and solve for R. Watch, I'm going to put a line down the equal sign. I want to get R isolated by itself. So what do we got to move away from the R? We got to move the T away. And it's distance equals rate times time. So to get rid of it, times means I have to do the opposite. I got to divide the T away. So I'm going to divide the T on both sides. It's going to look a little weird, but it gets R by itself. And then my answer is D divided by T, distance over time. I'm going to leave it like that. That's it. That's my literal equation. I've solved for R. I'll give you another example. Here's a literal equation that you probably should know. Area equals length times width. A equals LW. This is multivariable. There's an A, there's an L, there's a W. But they stand for something. A is area, L is length, W is width. And we can do the same thing. We could solve for a different variable. We could solve for W. This currently is solved for A. It says A equals, but we could change it. We could put at the bottom W equals. We could isolate W, and what do we got to move away from the W? The L. So divide the L away. When we divide the L away, we get kind of a weird answer. A over L. That's it. W equals A divided by L. We've solved our literal equation. So there's just tons and tons of types of these. Some of them have some meaning, like this one has meaning. W stands for width. Width equals area divided by length. Some of them, like the second example we did, didn't have any meaning. It was just random X and Y's. But eventually everything should have some sort of meaning. So I want you guys to try. Here's your you try problem. Let's see if you're getting the hang of this. Your directions are to solve for Y. And your multivariable equation is 6x plus 3y equals 12. Right now on your device, hit the pause button and see if you can do this all by yourself and if you have the hang of it. And then when you're ready, check your answer. Okay, are you done? Are you unpausing the video right now? Because we're going to check your answer and see if you did this on your own, okay? So the directions say to solve for Y, so I got to pay attention to those directions. That means at the bottom, it has to say Y equals, not X equals. Pay attention to those directions. So if it's not a Y, I better move it to the other side. So what do I need to move over? Well, I need to move that 6x. So I'm going to take the 6x away to the other side. Move it out of the way. That's going to leave a 3y. And then on the opposite side, 12 minus 6x. Well, I'm just going to write 12 minus 6x. I can't put those together because 12 and 6x are not the same thing. They're not like terms. And then I got to solve for the y, so I got to get rid of the 3. So I'm going to divide by 3 on the left and right. And it's going to be a big division, a big fraction. Divide everything by 3. Gets rid of the 3's, gets the y all isolated like we wanted. But it also means I got to divide 12 divided by 3. And then I have to subtract 6 divided by 3. 6x divided by 3. So y is going to equal 12 divided by 3 is 4. And minus 6x over 3 would be 2x, because 6 divided by 3 is 2. So our answer is y equals 4 minus 2x. And that's it. How'd you do? Did you get it right? Did you make any mistakes? Because if you did, you need to check what was my mistake. What can I do to not do that next time? So kind of look through your work and see how you did there. Now we're going to do another thing in this video. We're going to talk about which equations are multivariable and which are single variable. So in a minute, I'm going to flash 6 different equations up on the screen. In fact, I'm going to just do it now. And I want you to pause the video and try to identify which ones am I going to say are single and which ones are multi. And you might want to write this down in your notes. I think it would be nice to have this written down. So pause the video, write everything down, and circle or label your multi and single variables. Go. Okay, all done? Let's see how you did. So I'm going to go through each of these equations. The first one, 5x plus 4 equals 9x minus 4. That's single variable. It's all x's. So I bet you if we solved it, most likely we'd get a pretty nice answer. I'm not actually going to solve it right now, but I'm not expecting one of those messy solutions. The second equation has x's and y's. That's multivariable. It's going to have a messy answer. Whether I'm solving for x or solving for y, I don't know. Someone would have to give me some directions. The third one looks like it stands for perimeter. Perimeter is 2 lengths plus 2 widths. Totally multivariable. Also a literal equation because P stands for perimeter, L for length, W for width. The fourth one only has m's, so it's single variable. The next one is also single variable. I know you see that x to the second power, but it's still an x. There's only x's. There's only one variable. And then the last one's multi. There's a v and there's a w, so multivariable. So I hope you were, just like me, able to identify each equation and see which ones would be single versus multi. All right. So last thing for our notes, we're going to build a big T-chart of single variable equations versus multivariable equations. And we're going to do this just to kind of like organize and summarize our work here today. So here's what I'm going to write in my T-chart. And if I go fast, pause and write this down. Single variable is exactly like it sounds like. You have one variable only. So I could make up kind of a random example of one variable. Here's one, I just made it up. 4x plus 3 equals x plus 1. It only has x's, so it's single variable. Multivariable is when you have 2 or more variables. So it might be like you have an x and a y, or it could be like you have an x, a y, and a z. Like you could have a lot of different variables. So 2 or more variables is considered multi. And here's an example. I made this one up too. 3m plus 4h equals 5. That's multivariable. There's m's and h's. Another thing about multivariable is sometimes we call them literal. Literal equations are multivariables that have meaning to them. They're usually like formulas. So like distance equals rate times time, or area equals length times width. Those are literal equations. They have lots of variables, and the variables mean something. So I'm going to kind of go back and forth. Sometimes I'm going to say multivariable. Sometimes I'm going to say literal. They're kind of interchangeable. If you're solving a one variable problem, most of your solutions are what I would call a clean answer, where you're going to get a number like x equals 7, x equals 3.5, x equals 100. And most answers for multivariable are going to be what I call messy, where x equals a whole bunch of stuff, and it might have a meaning or it might not. So I like to keep that kind of in mind, because when you get a multivariable problem, people feel uneasy about those messy answers. All right, well, that really wraps up our video, you guys. I hope you kind of have a handle on single variable versus multivariable. It's really the same process. Put the line down the equal sign. Just know that there's a difference in your answer versus the clean answer or the messy answer. Thanks for watching, guys. I'll see you in class.